In this series of videos, we're going to simplify expressions with exponents, we're going to evaluate expressions involving exponents or radicals, and we're going to find the domains of algebraic expressions. In this first 4 examples, we're going to simplify by factoring. So we're going to look at what's common to each term. So what we find here in this first example is that we have the variable x common to both terms. We're going to see the smallest, the lowest exponent that they both have. So out of the 2 of them, the lowest exponent is 2. Therefore, let's change my color here. Therefore, we're going to factor out an x, and we're going to take out the x squared. Now when we factor out, I'm going to show you basics, even though you probably think you don't need to know this. Hopefully you can see over here where we're going to be going. So this might be a helpful tool for you when we end up with rational exponents. So we're going to divide out that greatest common factor, x squared, and that's going to leave us in the parentheses 2 minus x. And that's really how you end up factoring. So that's how we factor. Let me change this pen here. There we go. Pencil. Okay, let's try another. So we've got 2x cubed plus x squared. You can go ahead and try this one. You're probably way ahead of me. I see that they both share an x, so I'm going to factor out an x. The exponent, the smallest exponent between those two is a 2. So that's what we'll factor out. So I'm going to divide out an x squared to see what is left in parentheses. We've got 2x for the first term, and then the second term is 1. So x squared times the quantity, 2x plus 1. And you were probably doing this really well without showing any work, which I appreciate. However, let's make sure that you can do this with rational exponents. So we look at the 2 terms. Not only do they both have the same variable, but they also have a greatest numerical factor of 2. So I'm going to take out a 2 and an x. But what's the exponent of x? Well, we're looking at the exponents between 1/2 and 5/2. The smaller of the 2 is 1/2. So that's what we're going to take out. So we take out the smaller of the 2 exponents. So I'm going to divide that out from each term. That's going to leave me with a 1 for the first term, plus 4 divided by 2 is 2. And then remember, when you have division of exponents, you're going to subtract. So that's going to equal 5/2 minus 1/2, which is 4/2. And 4/2 is 2, x to the second power. So our answer is 2x to the 1/2 times the quantity 1 plus 2x squared. Now we'll be factoring quite a bit with rational exponents as we work into calculus and work with derivatives and even later on in integrals. So now you can go ahead and try this, see if you've got it. Okay, so press pause, try this one on your own, and then come back, and we'll be hopefully getting the same answer together. So I look at this expression, 2x to the negative 1/2 plus 3x to the 5/2, and I see that they do not have a greatest numerical factor. However, they have a variable factor that's in common. So I'm going to factor out an x, but what exponent of x? Well, I look at the 2 exponents, and between these 2 exponents, the smaller of the 2 is negative 1/2. So that is what I am factoring out, x to the negative 1/2. X to the negative 1/2. So x to the negative 1/2 is on the outside of my parentheses. What goes in the parentheses, the first term would be a 2, because these 2 factors cancel out. And then what we have is, let's go back to my favorites. Then what we have is 5/2, very thick pen, need to fix that, 5/2 minus -1/2 is 6/2, which is 3. So 3x cubed. Now, it might be a little odd here, so I'm going to go back here and just highlight this for you. This 3 is where this 3 is coming from. Okay. This 3 is coming from the subtraction of the exponents. The exponent in the numerator minus the exponent in the denominator. So I'm just going to rewrite my answer real quick. X to the -1/2 times the quantity 2 plus 3x cubed. I'm going to box it, and there is our simplifying with factoring.